Okay, so we're back with another very brief video today. Reason for that is we're still on definite integrals. You've got the note on the method and a worked example from the last lesson. All I'm going to do today is provide a further worked example, but this time we're focusing on trig functions. We already know how to integrate these trig functions, so we can then operate with them when they appear as definite integrals. So I've got my function here and we've got our upper and lower limits. So we know the method is going to be to integrate the function, substitute the upper and lower limits in, and then we take the lower limit value away from the upper limit value. So we'll go ahead and do our integration. It looks ready for integration, so I don't have any preparation to do. So making use of my square brackets as before. I've got a 4 cos function, so we know that that integrates to 4 sine. I then want to check my bracket to see if this function involved the chain rule, but because I've only got one x, then the chain rule doesn't really come into play in this one at all. So I can close off my square bracket, no need for plus c, we talked about that in the last video, and then I can transfer my upper and lower limits to the end of my bracket. All I'm going to do now, substitute the upper limit into this function and then the lower limit. So we get, for the upper limit, 4 sine pi upon 3 plus pi upon 3, and we're going to subtract from that 4 sine pi upon 6 plus pi upon 3. Now you need to evaluate both of these brackets, so we're going to get 4 sine pi upon 3 plus pi upon 3, that's just 2 pi upon 3. And we're going to subtract from that, I'll just keep that in a bracket just now, subtract from that, we get 4 sine, this is 2 pi upon 6, if I was to change it to 6, plus a pi upon 6, so that's giving me 3 pi upon 6, but we know that that's the same as pi upon 2. So now we're into our exact values, so if I deal with this one first, 2 pi upon 3, that's in the second quadrant, sine in the second quadrant is still positive, so this value sine 2 pi upon 3 is exactly the same as the sine of pi upon 3 in the first quadrant. So I could use my exact value triangles. I've got 2, 1, root 3 and pi upon 3 is down here. So the sine of that, opposite over adjacent, I get 4 times root 3 upon 2. And the second one, wee bit easier, sine pi upon 2. I know from my sine graph at pi upon 2 I'm at a maximum value of 1. So this is going to be 4 times 1, which is just 4. And then I can simply evaluate this. This is 4 and then I'm going to divide by 2. So it's the same as multiplying by 2. So this will give me 2 root 3 minus 4. And I'm just going to leave it as an exact value. Not going to bother going to my calculator. So that's how we deal with these trig functions as definite integrals. Things to watch out for when you get into the textbook exercise. Perhaps your limits are not going to be in terms of pi. You can still get, whole number integers as your limits. So you could still be putting 3, putting minus 2 in as your upper and lower limit. All you'll need to watch for is when you calculate that down here, make sure your calculator is in radian mode. Okay, so must be working in radian mode when we're dealing with trig functions in any of the calculus we do. So hopefully that will get you into the next exercise, which is exercise 12G. I'll put a selection of the questions I think are worth doing on the assignment that I put up on Teams. So good luck with that. As always, get in touch if you have any further queries.